Hello everyone, welcome back to my channel. Today's video is all about correlation analysis in R. We'll explore what correlation is, how to calculate it in R, and how to interpret the results. By the end of this video, you'll be able to confidently analyze relationships between variables in your own data. So, what is correlation? Correlation describes the strength and direction of a linear relationship between two variables. In simpler terms, it tells us how much two variables change together. Okay, a positive correlation means as one variable increases, the other one tends to increase as well. A negative correlation means as one variable increases, the other tends to decrease. It's simple and easy, right? No correlation means there is no correlationship between the variables. Okay, no linear relationship between the variables. Now, if you want to use R to calculate correlation, we generally calculate Pearson's coefficient. There are different ways to measure correlation. The value of Pearson's correlation is between -1 and 1. -1 indicates a perfect negative relationship. 0 indicates no correlation, and +1 indicates a perfect positive relationship. Okay, so let's dive into R and do this analysis. Okay, I've opened up R. Now, I already have this dataset which I'm going to use in my working directory, so I don't need to set a working directory. I've used this library read Excel to read the data. Control plus enter. Okay, control plus enter again on this one. Here you can see this dataset. I can take a look at it. I can write the view df function or just click it from here. I have simply clicked it. There you go. You can see the variables in this particular dataset. Okay, now what we want to do is we want to calculate correlation for just the numerical variables. So first of all, we will set numVar, the dataset with having just numerical variables, df, okay, comma, supply. This function is basically used to create a list of numerical variables. Is.numeric will be used so that a list of numerical variables will be stored in the numVar element. Okay, so the next step we'll do is we'll set an element correlation matrix, use the core function, and inside we'll write numVar, which we've already calculated. This will give us a correlation matrix. Okay, we can view the correlation matrix if we want to using the view function. Correlation matrix. Okay, control plus enter. You see here we have all the numerical variables and their correlationship with each other. Next step is to plot and visualize it using a heat map. So what we're going to do here is very interesting. So stay with me. We use the core plot function. Inside we're going to write correlation matrix, comma, method is equal to color, type is equal to 4. Okay, and I will also set the text size by using tl.cex.
Naughty, you teasing me, you naughty.
Okay, and this will be 0.8 or 0.7. Okay, next one will be tl.call for the color is equal to, I'll set it as black. Let's visualize it. Control plus enter. Okay, here we go. If I want the type to be upper, I can do this. If I want it to be lower, I can do this. You see here the lower one. Now we've calculated Pearson's correlation in this video, but generally we use this. But if there's a non-linear relationship, then we can calculate Kendall's correlation as well. How we're going to do it, we can just write method here. Method is equal to Kendall. Okay, this way it will calculate correlation using the Kendall method, Kendall's correlation. That's it for today's video. I hope you liked it. Please subscribe to the channel. There are more fun videos to come. Bye bye for now.